Hello, this is Les. Welcome to my YouTube channel. Today I'm going to show and run 3 different Stirling engines. This is the first one I made many years ago. It has a cast metal base. This is the form that I made for casting it. And other than that, there's really nothing very unique about it. If you're interested in Stirling engines, you probably understand the principle very well on how they work, but I'll give a brief explanation. The Stirling engine was developed back in the early days with steam engines, and they are a heat engine, which basically means they use heat from burning a fuel to convert the energy of the heat into mechanical energy. In the case of the Stirling engine, the heat source is external, and you have this little volume of air that's enclosed in this cylindrical tube, and one end is kept very hot and the other end is cooled. And that's the purpose of these louvered fins on this end, is to radiate the heat away. And the Stirling engine basically heats and cools this little volume of air in this cylinder rapidly, and heating it and rapidly cooling it, which causes the air to expand and contract. And the expansion and the contraction of the air runs the power piston. And the ingenious aspect of the Stirling engine is that there's a displacer tube in the inside of the stainless steel tube, and that goes back and forth and displaces that volume of air from the hot end to the cool end. So when the displacer goes back and it displaces the air to the cool end, the air rapidly shrinks and causes a vacuum, and that pulls the power piston in, which moves the crank and moves the displacer to the cool end. When the displacer is at the cool end, it forces the enclosed amount of air to the hot end, where it's reheated and expands, causing an expansion of the air, causing the power piston to push out. So that cycle is repeated as the displacer goes back and forth. The next engine is very similar. The unique aspect of this engine is that it has what's called the Scotch yoke. So instead of a connecting rod connecting the crankshaft to the displacer shaft, it has this Scotch yoke. And that enables the engine to be shortened up quite a bit. This engine would probably be another, I don't know, 2 inches, 1.5 inches longer. So it would get quite long if it had a regular connecting rod in here rather than the Scotch yoke. And then the power piston is on the top, so it's at right angles to the displacer. The last engine has a free piston displacer. So when the power piston compresses the air, it pops this fairly thick diameter shaft up, because this acts as a small piston, and the displacer is attached to that, so it pops up and moves the displacer from the hot end to the cool end. Okay, I'm going to start by running this engine first. It runs on denatured alcohol. So this is the little alcohol lamp right here. I don't think it'll take very long for this engine to get heated up and start running, but if it does, I'll just cut the camera off for a while. Oops. So there's the flame on the hot end. The engine seems a little bit stiff from setting all these years. I oiled it up. Typically I use a dry graphic lubricant on the power piston and just a regular light oil on the crankshaft bearings and the crank pins. The Stirling engine will continue to run because the hot end retains some heat. So they'll typically run for a short while after the heat source is removed. For the size of the flame on the engine right now, it should be running a lot faster. I suspect it needs a good cleaning, especially the bearings. They seem a little bit tight. I think I'm starting to run out of fuel now. The wick is starting to burn. So I'm going to blow this one out and I'll start another one. Yep. Okay, this is pretty much similar to the first engine, except as I mentioned, it has the Scotch Yoke linkage that moves the displacer, and then the power piston is mounted at 90 degrees, where the other engine had the power piston and the displacer parallel. Well, I think this one is should be about out of fuel, so I'm going to blow it out and then start the last one. And again, it's going to run for a while with the heat removed because of the residual heat in the cylinder. The cylinder is still quite hot. And this last engine is called a ring bomb engine, and I followed a picture in this book right here called the Stirling Engine Manual, written by James G. Rizzo. And in the book, there was a picture of this ring bomb engine right here, and it was designed by James R. Senf. So I generally followed that all the way. I made my own modifications to the design. None of these little engines were built with very big fuel reservoirs, so can't run them for too long. This metal part right here is just a heat shield to try to conduct some of the heat after it's heated the hot end of the displacer cylinder, to keep it flowing out. Probably would work even better if I would have had some kind of a stack along the side here to draw the hot combustion air up and away from this large plate on the top that holds the power piston right here and the displacer piston, the displacer cylinder. Now when this engine starts running, it'll typically rock back and forth before it develops enough power to go a full 360 degrees. And it'll run equally well in either direction. The other Stirling engines won't do that. They're timed to run in one direction only. But this one will run in either direction. Another thing about this particular engine is it runs very uneven because the displacer shaft up here, or piston, this is actually a piston, tends to stick a little bit, especially when it starts running faster. And of course, if the displacer isn't moving, then the power piston isn't going to work. I'll stop it and run it in the other direction. There you go, 3 small Stirling engines. Thanks for watching.